Okay, so we're gonna find the equation of the tangent line to this curve, and that says 2 at the end over there, at this point. Now, this is the one that we ended with where I made a mistake, so we're gonna redo it. We'll start with this one, but we're gonna do more after this one. So starting with this one, rewrite it, and what you wanna do is you wanna do the implicit differentiation. And again, we wanna be real careful because anyone can make a mistake. Okay, so again, you implicit differentiate. You're gonna do, what's the derivative of 3y squared? Well, the 3 comes out. That's just that's just the constant, and then it's the derivative of y squared, which is 2 times y to the first times the derivative of y, which is just dy dx, minus 6 times the derivative of x times y. Right, now the derivative of x times y, you need to know that you need to use product rule. This is like f, this is like g. The derivative of f, right, what's the derivative of f times g? By product rule, it's f prime times g plus g prime times f. So the derivative of x is 1 times g is y, plus the derivative of y is y prime, or dy dx, whatever notation you want to use, dy dx, times f, which is just x, plus the derivative of 2x cubed is going to be 6x squared, minus 5 times the derivative of y is dy dx, is equal to, and then you differentiate the right hand side as well. The derivative of 2 is just 0 because 2 is a constant. Now you could sit here and look and distribute and find, get dy dx by itself on one side of the equal sign. So as a matter of fact, since I messed up last time, I'll show you how that's done. 6y, and I'm going to write it as y prime. And again, make sure you know that these are the same thing. Minus 6 times y, minus, did I mess this up? 2y, nope, minus 6x y prime. Right, when I distribute the minus 6, plus 6x squared minus 5 y prime equals 0. And now I'm going to combine, or I'm going to move everything that doesn't have a y prime in it over to the other side. So every term, so this doesn't have a y prime in it, this doesn't have a y prime in it. So I'm going to move that over. So I get 6y minus 6x squared divided by, this here is 6y times y prime minus 6x y prime minus 5y prime. And then you could factor out a y prime, and you're going to get 6y minus 6x minus 5 when you factor out that y prime. And then it's 6y minus 6x squared, and you can divide by 6y minus 6x minus 5 on both sides. And now you solved it for y prime, which again, it's not 100% necessary. You could plug in this point, right, into this equation and then solve for dy dx. But okay, so now I've solved for dy dx. I solved for y prime, right? It's equal to 6y minus 6x squared over 6y minus 6x minus 5. And what you're going to get here is that when you plug in the point 2 comma 1, make sure you know 2 is an x value, 1 is a y value. What do we get? We get 6 minus 2 squared, because x is 2, is 4, minus 6 is 24, over 6 times 1 minus 6 times 2 minus 5. Let's see what we get here. 6 minus 24 is negative 18. 6 minus 12 is negative 6 minus 12 is negative 6, minus 5 is negative 11, and I get 18 over 11, which is the desired slope, okay? What you now do is you just write the equation of the line at this point. So you have a point and you have slope. So y minus y1 is equal to mx minus x1, x1, okay? Y minus y1 is 1 is equal to the slope, 18 over 11, x minus 2. And then this is the equation of the tangent line, and you're done. Again, you could have just plugged in, 2 in for x over here and over here, right? And then solve for dy dx. But you could also do it this way. Let's do other homework problems. So let's see what else we got. So it's asking for another one. It says find the, for 3, 6, 1, it says find the slope of the tangent line to the hyperbola x squared minus y squared equals 1. So this is a hyperbola. They want the equation of the tangent line at the point 2 comma square root 3. And you could even check that this point is on this curve, right? So if x is 2, you get 4 minus the square root of 3 squared is 3, and 4 minus 3 does indeed equal 1. So this point is on this curve. And that's a good way to kind of get an idea that you want to make sure that the point that they're talking about is actually on this curve. Okay, now we implicit differentiate to get the equation of the tangent line. That's what this question's asking. Read it. It says, oh, it just says find the slope. So we don't even need to find the equation. It just says find slope of the tangent line. And we don't even need to find the equation. So that just makes it one less step. Okay, find the slope of the tangent line to this curve at this point. Okay, and again, we just implicit differentiate. So we have this as our relation, and we differentiate with respect to x. So the derivative of x squared with respect to x is going to be 2x times the derivative of x with respect to x, which is just 1. And I don't need to write it. Minus the derivative of y squared with respect to x is 2y times the derivative of y, which is dy dx. The other one would be dx dx, which is just 1, right? The derivative of x, right, we write it sometimes like this for a reason, because this x is sort of like on top, and it just becomes dx over dx, which is just 1. Okay, because it's something divided by itself sort of logic, okay? But anyways, yeah, so we don't need to deal with that. When we're differentiating with respect to x, it's just regular differentiation. But here we have it where it's y squared. So we got to be a little bit more careful. We got to do chain rule, right? We got to do 2 times y to the first times the derivative of the inside, which is dy dx. And now again, I could sit here and I could solve for dy dx, or I could plug in this point. So I have 2 times 2 minus 2 times the square root of 3 times dy dx. I don't know what that is. And I messed up my differentiation, because what's the derivative of 1? 0. And then this is 0 over here. And then I can solve it for dy dx. This is negative 4 on this side. Negative 2 root 3 dy dx. And then I divide by negative 2 square root 3 on both sides. I'm going to get 2 over the square root of 3 as dy dx. If I rationalize the denominator, which is typical, we want to do that. I mean, they typically always do. 2 root 3 over 3 is your slope, m. And that's all they cared about. That's what they wanted, provided I didn't make any mistakes. So that's 3.61. Let's do 3.62. So now let's get anything going. So 3.6. Whoa. Okay. 3.62. Find the equation of the tangent line. So now they actually do want the equation of the tangent line. So find tangent line to y cubed minus 3xy squared. And this is going to take some time for us to differentiate. X squared minus xy equals 6 at a certain point. So the point that I care about is at negative 1 comma 1. Okay, so to differentiate, I'm going to get 3y squared times the derivative of y. I'm going to write it as y prime. Minus the 3 comes out, and it's going to be the derivative of x times y squared. And we got to use product rule. So it's the derivative of x times y squared plus the derivative of y squared is 2y times y prime times x. And I got to get that in that bracket, that times x at the end. Plus 2x minus, and again, by product rule, right? The derivative of x is 1 times g is y, plus the derivative of y prime times x equals 0, the derivative of 6. Differentiate both sides. Don't forget to differentiate both sides like I did. Now, at this point, I'm just going to rewrite and plug in. I'm going to rewrite it as 3y squared times y prime minus 3y squared plus 2y times y prime times x plus 2x minus y plus y prime times x equals 0, and I'm going to plug in now. So now plugging in, right, I'm going to get negative 1 is x and 1 is y. So what do I get? 3 times 1 squared is 1. It's just 3y prime minus, it's negative 3, 1 plus, this is going to be negative 2y prime. Did I do that right? Let's see. So y is 1. Y prime, I leave y prime. X is negative 1. So this is going to become minus 2 y prime. X is negative 1. It becomes minus 2 minus y is 1. Y prime, I don't know. X is negative 1. So it becomes minus y prime is equal to 0. And then I solve for y prime, which shouldn't be too bad. 3y prime minus 3 plus 6y prime minus 2 minus 1 plus y prime equals 0. Hopefully I did this arithmetic correct. 3y prime plus 1y prime is 4y prime minus 5. Oh wait, I didn't substitute for this y squared. Where is this coming from? Okay, so minus 3 minus 6y prime. Let's hope that's right. So what is it? 3y prime plus 6y prime is 9, 10y prime total. And then this is negative 5, negative 6 is equal to 6. Over here, I divide by 10. And I get that y prime is equal to 5, is equal to 3 over 5. And that's the slope of this tangent line. I use this point, negative 1 comma 1, and I'm done. So let's just do that right over here. Let's just write that. Y minus y1 is equal to m x minus x1. And then I know that y minus y1 is 1 is equal to m is 3/5 x minus x1 is negative 1, so it becomes plus 1. And then this is the equation of your tangent line, provided I didn't make any mistakes, right? That's obviously key. But yeah, this is the general idea on how we differentiate by implicit differentiation and how we use it. Let's do another one. Let's see what we have. So again, let's be a little more confident. Let's see. Let's feel it out a little bit better. So again, you want to find dy dx. They're asking for the derivative if x squared plus y is equal to log of y squared minus 1. And this is a great example. So they want us to just get dy dx. So I'll solve for dy dx even at the end. They just want this. They don't want anything else. They just want dy dx. So what you do is you implicit differentiate on both sides. You're going to get 2x plus the derivative of y with respect to x is dy dx is equal to, this here takes the role of like u. The derivative of log u is 1 over u times the derivative of u, which is 2y times y prime. Because, again, you're differentiating with respect to x, so you got to multiply by chain rule again. So you're going to get 2y dy dx, if I write y prime as dy dx, over y squared minus 1, 2x plus dy dx. And then you solve it for dy dx, and that's a little bit of a headache in this case. So how do I do this as fast as possible? The only way I see doing it is if I multiply by this y squared minus 1 on both sides. And I get 2y dy dx. And then I get, when I distribute everything out, I'm going to get 2xy squared minus 2x plus dy dx y squared minus dy dx is equal to 2y dy dx. And then what you have here is you got to group all the dy dx's on one side. So I'm going to move them all to the left. So I'm going to have dy dx y squared minus dy dx minus 2y dy dx is equal to, on the other side you have 2x minus 2xy squared. And then you factor out dy dx, you're left with y squared minus 1 minus 2y is equal to 2x minus 2xy squared. And then you divide 2x minus 2xy squared divided by y squared minus 2y minus 1 is dy dx. Again, provided I didn't make a mistake in my massive amount of fatigue. This is how you do this. And then it asks for other questions here. Basically, we just need to know how to do implicit differentiation well, is the whole thing.